All right. Thank you all for being here today. My name is Jeremy, and I'm really excited to tell you more about my venture, Tactus. So today I want to start off by just telling you a little bit about the deaf community. When it comes to music, there are a few other groups of people who are as creative as the deaf community. They experience music much differently from you and I, and it's in the form of vibrations. Objects that are resonant, like steering wheel, maybe they hold a balloon at concerts, we've seen that, or just really being at a loud concert or a loud venue, maybe something that we've all experienced a little bit as well. And vibrating dance floors are just some of the ways that the deaf individuals naturally feel music. As a result, there are actually quite many deaf musicians and dancers today, and I'll tell you a little bit more about that in a bit. But their adaptive method of experiencing music is quite restrictive, as it requires them to be in contact with a vibrating medium at all times, or just to be in an environment that is extremely loud. And of course, these vibrations that they're experiencing is only covering a small portion of what music truly is. It's mostly just the bass. And of course, that's not ideal. So we see how people can adapt to using the tactile sense to receive information that's usually received by the auditory sense. So my co-founder and I created Tactus in 2019 with the mission to create a medium that delivers crucial and meaningful information otherwise inaccessible via the tactile sense with tactile feedback, basically enabling a new sense and a new channel of information to flow through. And with no existing solutions that could fulfill the deaf community's needs for music, we got to work. This problem is experienced by 28 million people in the US who are deaf and hard of hearing, and actually 1.25 million coming from service in the military, mostly due to these intense loud sounds they experience, such as gunshots, explosions, and so on. This large community of deaf individuals have a robust way of communication via American Sign Language. But for them, music is still inaccessible, even though we found that roughly 85% of them have expressed that music is actually important to them. So our first device was made for a deaf dancer and Professor Lori Akin. I mentioned some of those deaf dancers that we've met. So we created this device for her so she can receive vibrational music on her body in a portable way that lets her experience it whenever she wants in real time while dancing. The design allows her to move around freely without obstructing her dance moves, that you can see here. And the system has 6 unique points of contact embedded to convey the full spectrum of music, giving them maximum level of musical information to a point where she's able to differentiate between the various different songs and genres as well. Lori and the rest of the deaf individuals we showed to really enjoyed this experience. But they all had one similar request, and that is the looks. They would like to be able to wear this out and about where they can be accompanied by music, but without drawing additional attention towards themselves. And you can see here, the harness type device just is not the look for them. So seeing the enjoyment that the deaf community got out of this device, we then just integrate the whole system into the textiles of daily fabrics. After multiple iterations of prototypes, while working together with our users, the result is a portable music wearable device that's embedded in clothing, allowing the user to experience music wherever and whenever and in a form that's specifically developed for the deaf community. It is made to look like a normal piece of clothing so that the user can wear this wherever they want without standing out. It captures the full range of music, not just the bass, and is completely wireless using a Bluetooth connection, and it's all powered with a rechargeable battery. We now have multiple units that are being tested with our users right now as we speak, where they're integrating this into their daily routines. Our user-centric approach while developing this technology has allowed us to transfer this technology into a usable product for the deaf community, and that's given us some positive feedback and results. And when we explore other spaces where this technology can be beneficial, we'd like to take the same approach of working with our end users. In the case of bringing this to a usable device in the military, we first have to look at the problems that soldiers face today. So As more technology is being integrated into the soldiers' gear and equipment, we see that it may cause a bit of an information overload for them. And when a soldier is in these situations, most of the time they really need their eyes and ears to be 100% focused on their surroundings. And these gadgets sometimes could be a distraction for them. If you're looking at certain information that's projected on your AR goggles, it means that you're not truly seeing 100% what is around you. And if you're listening to commands on your earpiece, it means that you're not truly hearing the sounds that are in your environment. So these technologies definitely have a lot of benefits in the battlefield, but in certain situations, when you need to be focused on your surroundings, this can be a type of noise. And speaking of noise, a soldier also experiences all kinds of other noise as well, right? We talked about those loud sounds that can cause a soldier to return from service without their hearing. These could be gunshots, explosions, a loud engine, flashbang. So these are all really intense visuals and audios that can potentially permanently or maybe temporarily inhibit your visual and auditory sense. And the thing is, in most situations, these are situations where a soldier absolutely needs to know what the game plan is. They're in vulnerable situations. They need to know what the next step is, where to go, who to follow, in order to get them to a safer environment. So in these vulnerable situations, as well as other times when communication via speech or visual is not possible, our solution can provide an additional channel of information and communication to flow through. With each point of contact on the device having the ability to send a unique signal, we have a large bandwidth to inform the soldier wearing the device. This can be implemented as a type of mapping on the user's body. And all the points of contact are actually targeted towards specific anatomical landmarks for optimal sensing. And the state of the technology can be easily embedded into fabrics, as we've shown in the device that can convey music through deaf individuals with low power consumption. And we discussed earlier how there are, obviously different requirements between commercial use and military use. And but the application of our technology gives a good starting point to further develop and make the necessary changes and upgrades to optimize it to be easily installed into tactical suits of soldiers while adding minimal weight to them. Moving forward in the project, we'd like to, of course, validate these military use cases. So in this project call, we'd like to take the same approach we have taken with the deaf community and work closely with our end users to develop a solution that is meaningful and useful to them. Chris Palmer, you mentioned earlier how people developing tech is not always aligned with people asking for the requirements. That's totally true. And getting feedback from the users, in this case, the soldiers, will allow us to develop a military-specific solution using the existing technology framework that we have built. Through the AFFOA network, we hope to get in touch with various groups and folks in the field, such as CAPE, the Combat Protective Assembly, to be able to further work closely with the soldiers. Alongside, we'll also be making the technology more manufacturable while updating the design to improve the user experience. This process will include evaluating every single user interaction point to ensure that it is intuitive to the user, ensuring that we use materials and designs that are part of a scalable manufacturing process. And after that, we'll take the produced devices and further distribute them to deaf individuals and deaf schools who have requested to try out this device. Our goal is to be able to produce these functional fabrics at a low cost to make this technology accessible to our target audience. By partnering with UMass Lowell, we will have the additional resources and support to accomplish these goals. Myself from Tactus will be leading the project with Lucas and Alex on my team, taking the lead on the development and testing of the hardware and software for the technology. Professor Liu will be supporting us in the electrical design of the system, as well as the testing to make sure that the device meets all the requirements we have set in place. Professor Nagarajan will be supporting us in the integration between the electronic system and the fabrics and textiles, while Ms. Claire Laponte will be supporting us in the coordination of the fabrics development at the FDC at UMass Lowell. So the specific use cases can really only be formalized after working closely with our end users, the men and women in service. However, based on the capabilities of the technology, we believe that it can be implemented in the uniforms of soldiers for simple directional commands in those vulnerable situations in order to get them to a safe environment. Communications in stealth missions when you cannot see or speak with your teammates, or just as a tool for the whole platoon to synchronize on, to be off on the same beat heading into a mission. And in the Navy, this can be a communication system when speech is absolutely impossible while working in loud engine rooms. And in the Air Force, this could be implemented into the uniforms or seat of the pilot to provide the pilot with additional spatial awareness or situational awareness. Going back to our commercial use case, the opportunities that exist once deaf people are able to access music is exciting and encouraging. The benefits of education for 60,000 deaf students in the US, music therapy for 40,000 and 2 million hard of hearing in the country that are suffering from severe mental illness, and also just for the whole community to be able to participate and create music is what really drives us to further develop this technology for the deaf and hard of hearing community. Hope that together we can bring this technology to the deaf community and also the military to help enrich both dancers and soldiers. Thank you very much. If you have any questions, feel free to drop by our booth and we can chat more.